Hi and welcome to Jared's Academy. Today's lesson is about finding the inverse of a quadratic relations. Before we find the inverse of a quadratic relations, we must consider one thing, that we must have the relation n vertex form in order to find the inverse. If you were to given the relation n standard form or factored form, we must convert it to vertex form in order to find the inverse of that relation. And here's an example how to find the inverse of this relation if we have it in vertex form, which would be 2x minus 1 to the power of 2 plus 3. This is a quadratic relation in vertex form. To find the inverse of this relation or any relation, this concept is that we exchange the position of x and y and we solve back for y. Just the position, not the coefficient. In case if they have a coefficient, any relation, any equation, we just switch x and y and we solve back for y. That's how we find the inverse of any given relation. So in this case, we do the same thing. We switch the position of x and y. So we have x equals 2 bracket, y minus 1, which f of x represents y, to the power of 2, and then plus 3. Now, our goal is to isolate for y in order to properly find the inverse of this function or relation. So what we do, we go from outside to inside. So we bring the positive 3 first the other side. X minus 3 equals 2, bracket open, y minus 1 to the power of 2. Since it's positive, when you switch side, you gotta switch sign, remember that. Now, to get the bracket by itself slowly, we get rid of 2. So the opposite of multiplication is division. So it means that dividing both sides by 2. So we have x minus 3 over 2 equals, we got the bracket by itself slowly. So we have y minus 1 to the power of 2. Now our next step is to get rid of the square to the power of 2 here. Now the opposite of squaring is square root. So we square root both sides. So remember to, don't forget to put plus and minus. Square root of x minus 3 over 2, which equal to y minus 1. Now, the last step would be to just bring the negative 1 the other side in order to find the inverse of this relation, and this is how we indicate the inverse of any relation. So, to bring the negative 1 the other side, outside the square root, so we're going to write again. I'm just going to rearrange this as half times x minus 3 is the same as x minus 3 over 2. To bring the negative 1 to the other side, outside the square root will become positive 1. From negative to positive when you bring it to the other side. Now this is the inverse of a quadratic relation from vertex form that we found. Now there's also another way of finding the inverse of a quadratic relation from vertex form without going through all these steps. And there's only one formula to apply. As long as you know your value for a, which was, if we look at here in vertex form, a was 2, and your h value was positive 1, and k is positive 3, which is, the vertex here is 1 and 3. So we already know the value of h and k. That's all we need to know to find the inverse of a quadratic relation. As long as we know a, h, and k, and here's a simple formula within one step to find the inverse. We have f at inverse of x equals plus or minus, and the formula is 1 over a, x minus k plus h. So now we go ahead and substitute for a, k, and h. So this would equal plus or minus 1 over a, which is 1 over 2, bracket open, x minus k, x minus 3 plus h plus 1. And here we go, that's the inverse within one step. And we already have it right here going through all these steps that we did earlier. So now it's up to you which method you want to choose, which method you're more comfortable. Both are valid, and I'm just gonna stop right here. And I'm hoping that you practice this question a few times in order to understand, then apply to different examples, finding the inverse of a quadratic relation, as long as you have it in vertex form, remember that. So Please don't forget to subscribe. And if you have any question, below the comment box, leave your comment and question. I'll be able to reply back. Thanks for watching. Till next time, wish you all the very best.